All right. Hello, everyone. Today we are going to present our project Smart Car OBD, and I'm Kret. And
my name is Irv.
Okay, all right, let's get started. Next, we are going to talk about our project overview. Firstly, the purpose of our project is to extract data out of the car through the onboard diagnostic protocol, or we can call it OBD2 protocol. And there are many applications to the data that we extracted out. First one, we can use it to monitor car driver behavior in logistic company. The second one, we can use to predict fuel usage in different routes. And the third one, it's for the car owner to faster diagnose their own car so that they can get their car to the garage faster. And next, what's OBD2 protocol? OBD2 protocol is a protocol that connects between the OBD connector and the ECU of the car. The ECU of the car gathers the information from the sensor inside the car. And if we want the data from the ECU from the car, we need this protocol to communicate with the ECU to retrieve the data out of the car. And next, we need a chip. That is our connector. This one is our chip. It's called Castel. It's from Chinese company. It can communicate with ECU through the OBD protocol, and it also supports 4G. So we have to put SIM card inside it. And next, it's also communicate with our server through the Castel protocol, which we use the socket to read the information out from this chip. Next, there are many data that we can extract out there, but for main data that we can extract out is Dtc code. It's the diagnostic trouble codes. It's a code that tells that our car have problem. And next one, GPS is the latitude, longitude, speed, and direction. And the third one is PID data. It's the data that's stored inside the ECU, getting from all the sensor inside the car. The engine coolant temperature is one of the example. And last one, stat data. This is the data that we are going to use for our project result in this project. What are we going to use? We are going to use the trip fuel and trip mileage and also the trip time. And next, it's our overall diagram. So first, the ECU will gather information from the sensor in the car, and then it will communicate through the OBD connector to the OBD2 protocol. And once the OBD connector get the information from the ECU, it will upload the data to our server, GCP server, through the socket. And then once our server have the data, it will upload to the database, which we use Azure Cosmos DB in this case. And this is done for the first section. The second one, we want to display the data to the car. So we use Raspberry Pi to retrieve the data from our database Azure Cosmos DB. We query the data out, and then we show it in our OLED screen to the I2C protocol. And then we can control the screen using our joystick to see different data that we want to show. And next, it will be our real demo. Thank you.
Yes.
This car is a Jazz year 2012. Our OBD dongle is connected to the OBD port right here.
Note that we have configured the IP address in the PC2 application developed by Castel.
Once the green light and the blue light is on, that means our OBD dongle is ready to go, and it sends the data to our server already. We establish our server in the GCP platform, and we run the code communication flow to start our server using socket. And then our server will receive the data from the OBD dongle. And after it receives the data will be pushed to cloud.
There's a many data package that we can use, but for this project we will use data package 4001, which contains data.
Our Raspberry Pi will get the power from the power output of the car over there. Alright, and after we have uploaded the data to the cloud, and now here we pull the data from the cloud into our OLED screen. And now we pull the data, we pull the trip travel, we pull the fuel use, and then we also pull the time spent, like the trip time spent. And here we display it into the LED, and we also use the button to change.
Let's see for the real use case.
Starting at 0 meter. Okay, it's going up to 40 meters.
We are driving the car.
We are driving the car around the condo, round and round. The first use is 0.25 meters.
And now it's 0.27.
Oh, 0.27. This guy consumes so much oil.
And we also have the time spent.
Time spent. This trip have used 13 and 44 seconds. And also we can extract many more value from this OBD. Thank you for our project, Smart OBD!